A phase shift oscillator is given, whereas GV2 is voltage gain of an ideal amplifier and it is a negative real number. Assume that the circuit oscillates with a stable frequency and a stable amplitude. What is the phased rotation of the signal between nodes V1 and V2? So what is the phase rotation between these two nodes? That's the question. Now, first we recognize that the circuit is composed by 3 identical stages. So if we create the open loop, we will see 3 identical stages in series. For the circuit to sustain stable oscillations both in amplitude and in frequency, it requires that in the open loop transfer, if we have a signal at the input, exactly the same signal should appear at the output, both in amplitude and in phase. So this means that the phase rotation from this point to this point should be n times 360 degrees, so that the signal comes at the output exactly in the same phase moment. And this is needed so that if you create the feedback, the signal repeats itself and hence a stable oscillation is sustained. This is derived from the Barkhausen criteria of oscillation. Clearly, the phase rotation from the start, so let's draw it this time here, from the start to the output and back cannot be 0, because an RC stage rotates the phase from 0 to minus 90 degrees. So phase rotation that is contributed by an RC stage only at DC for DC is 0. For any AC signal it will be slightly negative, a negative number. This means that the total phase rotation of the open loop cannot be 0. It should be something more than 0. So the closest number is 360 degrees, and n equal to 0 is not possible, so we are investigating now n equal to 1 or 360 degrees. So we have 3 identical stages and there is no reason why they should rotate the phase differently. So they should rotate the phase in exactly the same way. So in order to have oscillations, the total phase rotation should be 360 degrees, and when we divide it by 3 identical stages, we'll get 120 degrees. A quick check in the available answers and we identify the correct answer, 120 degrees, and this is the good answer. If we have here 120 degrees and here 120 degrees and here 120 degrees, all 3 together is 360. Or in the open loop, here 120 degrees, here 120 degrees, the sum is 360 degrees, which satisfies the requirement for oscillations of Barkhausen, and the circuit will oscillate. Thank you very much for your attention.